In this example, we're given the current of this capacitor, and we're going to determine the waveform for the voltage across the capacitor. And for capacitor, we know the current going through the capacitor IT, that is equal to C times dVt dt. Since we know the current, to find the voltage, we have the voltage that is equal to 1 over C times the integration of current. Since the capacitor is initially uncharged, we know that Vc 0, that is equal to 0. And from the waveform, we know that for time t that is greater than 0, less than 2, current IT that is equal to 10 milliamp. Then we can apply the integration. So Vt at this time period that is equal to 1 over C times integration from 0 to whatever time t, and the IT that is 10 times 10 to the power negative 3 d tau, and C that is 100 mu phi. That give us 1 over 100 times 10 to the power negative 6 times 10 times 10 to the power negative 3 t. That is 100 t. And for time t that is greater than 2, we know that it that is simply 0. And Vt that is equal to 2 milliseconds plus 1 over C, the integration of 0 dt, and this term is simply 0. So when t that is equal to 2 milliseconds, we can plug the value back into the previous one. So we have 100 times 2 to the power of negative 3, we have 0.2 volt. Then we can draw the curve t. I have a unit of millisecond, and this is a voltage, and I have a unit of volts. So from time 0 to 2 milliseconds, it will grow as a straight line and be stabilized at that number, and this value is 0.2 volts.